Man, what are y'all guys doing? Those welds look awful.
Yeah, we're trying to weld a pull-up rack together, but as you can see, we're not much of welders.
Yeah, I can see. I think I can help you guys out, though. What type of welds are you trying to perform here?
What type of weld? There's different types? I thought welding was just joining the materials together.
Yeah, dude, there's a whole bunch of different types of welds. Check out part 8 of the AISC manual, particularly table 8-2, to find a bunch of information on welds. For structural engineering, typically we either use fillet or groove welds. Fillet welds are typically the most economical as they only require a general surface preparation, like removing oil and rust. Anything that may lead to intrusion of foreign materials into your weld, which would cause porosity or cracking.
How is that different from a groovy weld?
Well, in a groove weld, you have to bevel the end of the steel plate in which you're trying to be welded. Complete joint penetration or CJP groove welds are great because as long as you use the appropriate electrode, the completed weld can be treated as having a higher strength capacity than the nominal capacity of the original member.
Sounds like we want groove welds, right?
Not always, bro. Beveling the ends of the members takes a lot of extra time, and time is money. Plus, there can be complications in the field with inspecting groove welds, particularly if you use partial joint penetration or PJP welds. PJP groove welds can connect two materials but do so from only one side and might not penetrate through the whole thickness of the material.
You mean like the PJP weld would only be seen from one side of the member? That puts a lot of confidence in having a good welder and good surface prep.
Exactly. In some structures, like bridges, PJP welds might not be allowed in some members, as it can be too costly to inspect to make sure the members actually got properly connected. There are also some fatigue and fracture issues to work through. However, AISC does have a list of pre-qualified PJP and CJP welds that are allowed to be used in steel buildings. Again, see table 8-2.
I love AISC. They think of everything.
Yeah. Anyhow, if you need the strength or performance of a groove weld, then you can specify it, but structural engineers try to use fillet welds whenever possible to save on the expense.
Let's do fillet welds then. What are they again?
A fillet weld basically joins two parts together by melting the two base materials along with the filler material, allowing them to flow together. The geometry of a typical fillet weld looks a little something like this.
Great. I think that'll work for our project.
Yeah, I think it will too. If this was a building, we would have to do some calculations to check the capacity of the fillet welds. In particular, these angled rungs could be tricky because it will have to be eccentrically loaded welds. Even for the concentric welds at the base of the frame, will have to be designed to handle the moment plight from the load.
I'm just ready to get back to working out. I think since our weight is pretty low compared to the strength of the tubes and the welds, that no one will die if the welds fail. So we can easily fix them and we can skip the calculations for now.
Maybe there will be another season to explain weld limit states.
Yeah, man, I agree with you. Let's keep the welding. It looks like you were trying to do a shielded metal arc weld or a SMAW. In shielded metal arc welding, you stick a rod that is covered in a flux. As the rod melts, the flux is also deposited on the molten metal and then acts as a shield between the liquid metal and the air to keep moisture or other impurities from becoming included in the newly formed metal.
Well, is that the best for our application?
It's a widely used and versatile welding process. It requires a little more than the power source and the welding electrodes to work, so it is often used for welds performed on-site. But since we are fabricating in the shop, let's use another piece of equipment that creates a quality weld, but it's a little bit easier to operate. So for this, we'll be using a gas metal arc welding, GMAW or MIG welding. Instead of powdery flux from the welding sticks, this will use an inert gas like argon or argon CO2 mixture to shield the newly formed material from impurities. This works well in shop where there are no winds to disrupt the shielding gas. This allows us to use a continuous wire feed to form the weld so we do not have to start and stop the welds and can maintain a fixed distance from the workpiece to create an arc, something I saw you guys were having a real issue with you earlier.
About that arc, exactly how does welding work?
Alright, so the short explanation of this is the fact that you're just completing an electrical circuit. Do y'all remember physics 2?
I remember physics 2 encouraged me not to pursue electrical engineering.
Ha! Let me make it simple. So this is your power supply and this is your electrical lead. In this case, this is your workpiece lead. You want to connect it to the metal that you're trying to weld. In your case, you connect it to the metal bench, which is fine because the metal conducts electricity and allows electricity to flow through it. Alright, so this is your electrode lead. This is where you connect your electrode in which you touch to the material. In this place, it would actually complete the circuit once you put it on it.
Okay, but that doesn't create a weld.
Yeah, it just creates a circuit. In welding, we don't want to directly connect the circuit, we want to almost connect the circuit. By placing the electrode close to the metal, but not touching it, we'll be able to build up electric potential between the electrode and the base material. This will cause an electric arc to jump through the air between them. The electric arc is what creates the intense amount of heat we need to actually melt the metal. Once this is created, we'll be able to continue to feed the filament material into the connection while we move along the workpiece until it is officially connected.
You make it seem so easy.
Well, it is. See? All right, let's do it.
That looks good. Let's test it to make sure it can hold our weight.
Wow, it looks like you learned a lot about welding today.
We sure did.
Too bad you don't know the first thing about doing pull-ups.